Hey everybody, this is Paul. In this video I'm going to be explaining the difference between a reference and a pointer in C++. So I went ahead and started a diagram here to help explain what's going on. And so I'll be explaining what this means as I write some code over on this side of the screen. The diagram will help to connect the dots as to what is happening here. So first, let's declare a pointer. So this guy right here I've got drawn is my pointer, and I've just named him PTR. And so let's go ahead and do that. So if we were to declare a pointer in C++ named PTR, we would just pick the type, and in this case we can just pick an integer type. So int star would create an integer pointer, and then we want to name our pointer PTR to match this diagram right here, and then we can just put a semicolon. And so what this line does right here is we've created this pointer now, and it has the name PTR, and PTR holds some sort of value, and the value it holds is going to be the address of the thing that it's pointing to. And since we haven't instructed it to point to anything, when this program runs, it's just going to get assigned some sort of random value. But a lot of times it'll get assigned the value 0. So let's go ahead and place a 0 inside of here to represent the value that our pointer gets assigned. So 0x in front of the number represents that this is a hexadecimal number. So we've created this pointer. It currently doesn't point to anything, and when we run the program, there's a good chance that we'll get assigned this hexadecimal value 0. So at this point, if we were to print PTR, we would see that PTR is equal to the value 0. Assuming that that's the value that got placed inside of here when the pointer was created. Okay, so now let's go ahead and create this guy right here. So on the next line, I'll create an integer variable, and I'll name this one var. And then when our program runs, var will get assigned some sort of address to live at. And so we'll assume that for our purposes, the address that gets assigned is the address represented by the hexadecimal number A. So if we wanted to, in addition to creating this, we could give it a value, and we could say int var equals 7. And what that would do is it would create this variable named var, and then it would place the value 7 inside of var. So then now let's go ahead and create this guy right here. We can do that by declaring a new integer variable. We'll name it foo, and we'll set foo equal to 21. So coming back over here, we need to add a 21 inside of here. Okay, so we've created this variable foo, and then we'll just say that foo got placed at address B when the program ran. So we've got a variable var holding 7, and var lives at address A. Foo is another variable that holds the value 21, and foo lives at the address B. So at this point, if we were to print var, we would get a 7. If we were to print foo, we would get a 21. If we were to print PTR, we would get the value inside of PTR, which would be the value that PTR is pointing to, and currently we're saying that's pointing to nothing, which is referenced by this value 0 here. So if we were to print PTR at this point, we would get a value 0. This value right here, when we put an asterisk in front of PTR, is saying, tell us the value inside of the thing that the pointer is pointing to. So the value we would get here is going to be whatever number is stored in the address 0. And since we don't know what that is, this is basically just going to give us a bunch of garbage if we were to print out the dereferenced value of PTR. We don't really know what the dereferenced value of PTR would give us at this point. So now let's go ahead and make our pointer point to a variable. So on the next line here, I'm going to say that PTR is equal to the address of var. And so the address of var is the hexadecimal value A. So when we write this line right here, what happens is the value stored inside of our pointer becomes the address that it's pointing to. Since var lives at address A, this assignment right here is going to place the address A inside of the pointer. So let's go ahead and update our diagram to represent that. So this line makes our pointer now point to var by placing var's address inside of the pointer. So now if we were to print PTR, we would get the hexadecimal value A, which is the address that it is pointing to. Now if we were to print out the dereferenced value of pointer, we would get a 7, because the dereferenced value of the pointer is saying, give me the value that is inside of the thing that you're pointing to. Well, we're pointing to var, and the value that's stored inside of var is a 7. So one thing we can do with pointers is we can make them point to different things. So let's make our pointer point to something else. Well, if we wanted to, we could make our pointer point to foo, and we could do that by saying pointer equals the address of foo. And so what this is going to do is it's going to place the address of foo inside of pointer. So the address of foo is B, that's where foo lives. So B is going to get placed inside of here, which is going to cause our pointer to point to B, and these values will update as well. So let's go ahead and do that real quick. So this is what the results of that line of code would do. Pointer equals the address of foo, puts the address of foo inside of the pointer. So now if we were to print PTR, we would get the address B, which is where foo lives. If we were to print the dereferenced value of our pointer, we would get the value that is stored inside the thing that the pointer is pointing to, and that would be 21. So we could keep pointing this pointer to different things by placing the address of the thing that we want to point to inside of our pointer. So that's how pointers work. So what is a reference? Well, a reference is kind of like giving either foo or var a different name. So let's go ahead and create a reference. So on the next line, I'll just do int, and then I'll do an ampersand. I'll name my reference ref, and then I'll make the reference be the same thing as var. We're making a reference and we're naming it ref, and we're saying that ref is going to be the same thing as var. So what that does up here now is it looks at this guy where var is, and it essentially gives us a new way to call this location in memory. So now if we wanted to, we could print var and we would see the value 7. We could print ref and we would also see the value 7, because both var and ref are two ways to reference this same variable right here. So unlike the pointer, the reference ref right here can't be moved. We created this reference to be the same thing as var, and we can't tell ref to now point to foo. So if we wanted to, we could make pointer point back to this location right here, and all we would have to do is we would say that pointer equals the address of var, or we could say pointer equals the address of ref. It would look at either one of those and it would say, okay, this is my address. It would place that back into here, and it would make pointer point back to this location if we wanted to do that. Basically, the main difference between a reference and a pointer is the pointer has the freedom to move around and point to different variables, whereas the reference gets assigned one time and it just becomes a reference to that location in memory. So in a nutshell, that's the big difference between a pointer and a reference. So thank you guys for watching. I appreciate your feedback. Let me know what you think about this video. Feel free to come up with other suggestions or topics that you'd like me to cover. I look forward to hearing from you. Thanks for watching. And if you haven't already, don't forget to subscribe.